Pause and copy, pause and copy, pause and copy, pause and copy. Let's talk about the theorem first. Okay, two things here. First of all, the theorem is saying that if a function is differentiable at a certain point, then it's also continuous there. But it's not saying the other way around. So, like Jordan is in Quebec, that implies that Jordan is in Canada, right? But it doesn't work the other way around. So Jordan is in Quebec implies that Jordan is in Canada. But the arrow in the opposite direction is not true. Jordan is in Canada does not imply that Jordan is in Quebec, right? I could be in Alberta. Okay, it's the same thing with this theorem right here. Okay, continuity does not imply differentiability. So if it's continuous, it may or may not be differentiable. Just like if Jordan is in Canada, I may or may not be in Quebec. But if I'm in Quebec, I am necessarily in Canada. Okay, that's the first thing I wanted to say. The other thing is that if you negate, if I have the statements Jordan is not in Quebec, and then I have the statement Jordan is not in Canada. What happens to these arrows? Well, logically, it turns out that these arrows here, they change directions. Okay, so Jordan is not in Canada. That implies that Jordan is not in Quebec. And Jordan not being in Quebec does not imply that Jordan is not in Canada. Okay, so two little bits of logic here that I hope are logical. Going back to the example. Okay, where is this function not differentiable? Well, the only things that jump out at me are x equals minus 1 and x equals 2. So let's see x equals minus 1. X equals minus 1, we have the function is not continuous. Function is not continuous. Okay, so if I take this guy here and I reverse it, if I say not continuous, and over here I say not differentiable, got these two statements here. Which way does the arrow go? Well, this arrow down here, this arrow, this guy is being reversed, right? Okay, not continuous is going to imply not differentiable. So at x equals minus 1, my function is not continuous. Therefore, it is not differentiable there. So just briefly, I'll write not continuous, therefore not differentiable.